this is Professor David J. De Los Reyes. My topic on my next lecture or blog is the discussion or the solution of a homogeneous differential equation. We are now on the second type of differential equation. We are now through with variable separable, and I give you example problems on the variable separable. So my topic tonight will be the solution of a homogeneous differential equation. It's another variation of differential equation. Okay, let's proceed, guys. This is now DE 16, lesson number 16, under differential equation. The subtopic is homogeneous. The kind of differential equation is homogeneous. It's different from the variable separable. Okay, let's try to bring out the form of a homogeneous differential equation. The form is something like this. M as a function of x and y times dx plus n as a function of x and y times dy equal to 0. The marking of this for it to fall under the so-called homogeneous differential equation, there's a note over here. M as a function of x and y and n as a function of x and y are both homogeneous, or meaning homogeneous are same kind, okay? Same kind and same degree in x and y. Meaning, if this is linear, this should also be linear. If x is linear, y should also be linear. That's the meaning of the so-called homogeneous. So if there is a linear in x, there should be a linear in y also. And if there is quadratic in y, there should also be a quadratic in x. Meaning their degree will be the same. It will not be, there is an x square and there is only a y here. If there is an x square, there should also be a y square for it to fall under homogeneous. It cannot be that there is an x square and there is no y square. It will not fall under homogeneous. So if there is an x square, there should also be a y square. If there is an x, there should also be a y for it to fall under homogeneous differential equation. Oh, that's the marking of the so-called mark of a homogeneous differential equation. To bring out the solution of this, we need a substitution. Okay, how to solve? There's a substitution. It's just like in the so-called integration by substitution. It is something like that. Okay, but this is not. This is different. Okay, for it to be solved, a homogeneous differential equation, in order for us to solve for it, we will let y equal to bx or x is equal to by. Then after the substitution of y equal to bx or x equal to by back to the given equation, then it will be reduced to a variable separable. So after the substitution, what will come out will now be a variable separable differential equation. So if it is a variable separable differential equation, we now know how to solve a variable separable differential equation. Okay, that's the concept or summary of a homogeneous differential equation. At least we now know the form, how we could determine if it is homogeneous. If there is an x square, there should also be y square. If there is an x, there should also be y. Okay, for it to be homogeneous. Homogeneous meaning they are of the same kind. Their degrees are same. Okay, that's the marking of a homogeneous differential equation. Okay, I will try to give you an example problem to illustrate the solution of a homogeneous differential equation. The given equation is x dy minus y dx equal to the square root of x squared plus y squared times dx. How do we know if this equation is a homogeneous differential equation? Okay, let's try to compare the degree. There is a square on the y and there's a square on the x. Okay, so that will be balanced. The power of x here is 1 and the power of y here is 1. Okay, so we got a degree 2 and we got a degree 1. Dissatisfy the degree 2 and dissatisfy the degree 1. So the given equation is a homogeneous differential equation. Okay, let's try to bring out the solution. To bring out the solution, we will use y equal to bx. Y equal to bx. Taking the differential of both sides, dy will be the differential of the right hand side, product, right? First times the differential of the second plus the second times the differential of the first. Right? Then we will substitute the value of dy back to the given equation. So we will follow this, x times dy is b dx plus x db, minus y, but y is bx times dx, equal to the square root of x squared plus y is bx, so if we try to square it, will be b squared x squared under the radical sign times dx. Okay? This cancels, right? So this is gone, this is gone. There's an x over here, there's an x over here. So actually we could cancel one x. So x will remain over here. So it will be x dv equal to the right hand side will be x is gone. So this should be the square root of b squared plus 1 times dx. Okay? We are now given a differential equation. Okay, from the look of it, it seems it's a variable separable. So by algebraic manipulation, okay, dv over the square root of b squared plus 1 equal to dx over x. Right? Because if we cross multiply this, it is this. So it can be written as dv over the square root of b squared plus 1 equal to the integral of the x. We separated already the variables. X function, b function, we separate the variables already. Proceeding with the integration, the integral of dv, we are now integrating, okay? The integral of dv over the square root of 1 plus b squared equal to the integral of dx over x. This falls under natural logarithm. For the left hand side, it's a little bit complicated. We will use the so-called integration by using trigonometric substitution. Okay, you recall your integration for trigonometric substitution. We will let b squared equal to tangent square of theta. Okay, therefore taking the square root b will be tangent of theta. Taking differential, db will be secant square of theta, differential theta. Therefore, dv now will follow this. The integral of secant square of theta, differential theta. The simplification of this, it will come out as 1 plus tangent square of theta. Okay? The square root. 1 plus tangent is actually the square root of secant square. The square root of secant square of theta, it will just be simply theta. Equal to the right hand side, natural logarithm of x, plus k1, okay? But if we will place a natural logarithm for that k1, there's no violation. It will still be a constant, right? But we can place a natural logarithm. Anyway, it's still a constant. So what will come out? The left hand side, the secant of theta cancels. What remains is only secant of theta. And if you recall your integral calculus again, if we multiply secant theta tangent theta plus secant square root theta all over secant square root theta, oh, hold on. Sorry for this one. I miswrote it. It will just be simply secant of theta plus tangent of theta. Okay? secant plus tangent is actually 1, right? But we could do it. Then if we try to expand the numerator, it will be secant square, secant tangent. And after multiplying this falls under natural logarithm. Okay? The value of u is secant and tangent. Because if we try to differentiate this one, it is the same as the product of the numerator. So what will come out will be natural logarithm of the quantity secant of theta plus tangent of theta equal to this is natural logarithm of x, natural logarithm of k1. We can put it under one natural logarithm side. The logarithm of the sum is actually the logarithm of the product, right? Okay. Okay, let's try to bring out the value of the resulting equation as a function of x. From the equation b is equal to tangent of theta. Tangent of theta is actually b over 1. So this should be b, this is 1. The hypotenuse will be the square root of what? The square of this plus the square of this, then take the square root. That's the hypotenuse. After computing the hypotenuse, secant is actually hypotenuse over adjacent. It will be the square root of 1 plus b square over 1, or just simply 1, or the square root of 1 plus b square. Okay, so going back to this, substituting these values here, this will be natural logarithm of b plus the square root of 1 plus b square equal to the natural logarithm of x. Then there's a natural logarithm here, there's a natural logarithm here, and if you try to take the antilog of both sides, okay, actually this cancels out. It will be something like this. Okay? It will just be simply, it will cancel out. Natural logarithm, take the antilog, it will just be simply the given function. Antilog also, it will just be simply the given right hand side. Therefore b is square root of 1 plus b square equal to k1x. But what is b? Because the original variable is x and y, right? From the relation of y is equal to bx, y equal to bx, b will be equal to y over x. Okay? We will replace all values of b by the ratio y over x. So this should be y over x plus the square root of 1, y over x quantity square equal to k1x. Okay? This should be y over x. The term inside the radical will 1 times x square will be x square plus y square all over the square root of x square. And the square root of x square is x. It's a perfect square. I bring it out, it is 1 over x equal to k1x. Then multiplying all terms by x. Okay? This is gone, so it will be y plus the square root of x square plus y square equal to k1x times x will be kx squared. This is our final answer. Oh, that's it, guys. Oh, that's an example of a homogeneous differential equation. So actually, after the substitution of y equal to vx, what comes out will be a variable separable differential equation. And your only problem now is we will pray that the resulting integration will be an easy one. So if whatever integration that will come out, bring it out, your knowledge of integration. And unluckily for the left-hand side, it's a trigonometric substitution. Okay, a little bit complicated. If you do not know your trigonometric substitution, you're cut. Okay. Natural logarithm of secant theta plus tangent theta equal to the natural logarithm of k1x. Oh, that's it, guys. Good evening, Los Angeles.